Oh, okay. All righty. Uh, we're all back, I think, in the room. And so now I think we'll start the main part of our meeting. First, I want to welcome all of you, especially the new people, and especially the people who are coming from places, I don't know where they live, but anyway, they are far away places. And I want to thank the volunteers that have worked to put this meeting together uh, and to make it happen. First, we have Fanny. She's going to take care of the recording because our speaker said it's okay to record her. And that recording will be up on our website in a while. Then Abigail Giamfi, she is a graduate student at UC Merced, but she will write the meeting summary for the Vortex, which is our monthly newsletter. And uh, then we have Sheila Ye, who isn't here, but she does an important role. That flyer that you all saw, Sheila does that. And then we have Michael and Tony, and you met Michael, but Tony, you haven't met. And both of them are involved in the um, the contest aspect of our program. We have a volunteer contest that is based on the speaker's talk. So if you just pay attention to Shelby's talk, there's a reasonable likelihood that you will be able to answer correctly three multiple choice questions. Now, if you do that, then Michael is the one who is going to uh, oh, Hillary Epley. Did you let her in? Okay.
Yep.
Okay. Anyway, Michael's the one who's going to tally up the winners. And then he's going to let me know who the winners are. And then I'm going to ask you for personal information, your address, because I can't send you the prize unless you tell me where you live. And then the prize will be sent to you. So, um, if you are interested in that, this contest occurs after the meeting. Okay.
I,
So,
I will send the question out at the end of the presentation or
right,
near the end, and then reply the answer to me only. Do not do reply all.
right. That's a very important point, Michael. Okay.
So
Now,
since
it turns out that all of these volunteers I've been talking about, they are really interested in the intersection of chemistry, social justice, and sustainability, just like our speaker. The thing is that our volunteers in the California section are interested in those subjects as it relates to women chemists. And we, especially Mary Singleton and I, are very happy to say that the number of women chemists has increased in the last 50 years. And we think that our meetings have maybe played a role, a little bit of a role. Um, and we lead by example. Okay. So this intersection is the intersection that also is of primary interest to Shelby. And she's interested in social justice, a term which was not in graduate school in my day. Uh, but anyway, uh, chemistry and sustainability. Uh, some of her work in sustainability that isn't on the flyer has to do with coffee. Okay. But today she's going to talk about this big study that she did in 77 distinct neighborhoods in and around Chicago. Now, you all know from historical reading that Chicago was a big industrial area, and especially in the early 1900s. So it was a pretty messy place, and there could be lots of heavy metals in the various neighborhoods, but how many, how much, the concentration and so forth, that's what Shelby and her team have been investigating by analytical techniques, which I'm sure she learned in graduate school. That you can learn in graduate school. Okay. So she wanted to relate the various 77 areas that these people live in to topics such as social justice, demographics, perhaps the racial and ethnic balances in these various neighborhoods. And that's what she's going to talk about today. So take it away, Shelby.
Thank you. And I assume I am able to, oh, I will have to request that I can share my screen.
And I'm allowing it.
All all right. Um, I trust that everyone is now able to see it. As Elaine said, I'm going to be talking about my work on mapping heavy metal contamination in Chicago's neighborhoods. And I have been doing various iterations of this work. I guess if you think about it as like one big project with little sub projects in it for over 20 years. A brief timeline of what I have been doing. So, um, so in 2004, which is slightly more than 20 years ago, I began working with undergraduate students doing trace metal analysis of soil samples. Started with, um, yeah, so that's when I started this. And in 2012, um, the first large participatory project, um, the first large participatory project that I worked on um, was underway for particular social justice reasons in the city of Chicago. And and then in 2017, we formed a collective called a Youth Participatory Science Collective, which I will talk about. And then in 2021, worked with some students during the pandemic to create an environmental injustice story map, which I will show you all. And in 2025, this year, we started a new mapping project and have set a goal to acquire samples from all of Chicago's 77 community areas. And Elaine, if it's okay with you, I'm fine if people want to ask me questions as I'm going along, or they can, if they put things in the chat, I may or may not see them, but I'm okay answering questions if people have things that come up as I'm talking.
I have a question. I don't know if I missed it, but who's supporting this project and where's your base of operation?
Oh, you are right. I didn't say it. Um, so I am at Northwestern University, and for a while, part of this project, this youth participatory science piece of the project, was sponsored by NSF. And other than that, most of my support is uh, through small grants at Northwestern University, um, whereby I basically get funding in order to pay undergraduates to work with me on the project. So that's the funding. And that's where I am. And apologies that I didn't say that in the beginning. So, so I want to talk, as I was in the breakout session earlier, I was hearing from someone who is attending today because they grew up in Chicago and we're talking about, what a polluted place it was, what an industrial place it was. And that is true. In the city of Chicago, there were two like in the city limits, two coal-fired power plants, Crawford and Fisk, and they were built in the early 1900s. And when the Clean Air Act, was passed in the 1970s, they said, "Oh, these plants are so old, they will just be left, they'll close soon, so they don't have to." Um, they don't have to scrub, they don't have to put the scrubbers on and all this expensive equipment. But of course, the owners of these power plants were like, "This is great. We can operate and very cheaply. And so even though we're not very efficient, we can just keep going because now we're saving a lot of money by not having to put these new controls into place." Um, and so by the early 2000s, there were environmental justice groups in the areas where these, were located. Both of these are located on the southeast side of Chicago, which is heavily, at this point in time, Hispanic neighborhoods. One of them is in a neighborhood called Little Village, which is, a lot of Mexican people of Mexican descent who immigrated from, Michoacan in Mexico, and, Pilsen, which, despite its name, is now also mostly, Hispanic area. These two neighborhoods, had environmental justice organizations that came about in part because of these issues and in part because of other environmental issues in their neighborhoods. Um, and we're like trying to shut down these coal-fired power plants. So, um, we, um, as I mentioned, in 2004, I started collecting soil samples with students, and, it was part of a class. I was the general chemistry lab director, so it was part of their laboratory course to analyze soil samples for metals. But this was the first time that we were really like, um, decided to develop a project around a particular social justice issue. And all of the students participated in that project in various ways. So, what we did, or what the, project looked like, is, um, we created, so one student, was doing an independent study, for his senior thesis. And so he created this sampling plan, and you can see, um, if you can see this little yellow, uh, triangle and this, uh, like blue triangle, I think you can see my, those are the two, power plants. And, all of these, blots, it looks like a Rorschach test or something, right? Uh, these black, these black dots are showing the concentration of lead, at the various points. And so, the sampling plan was created, um, to like go out in spokes of wheels from the two coal-fired power plants. And then, the analysis was done. Um, we were trying to find out, determine that the levels of lead, mercury, and other heavy metals were a direct result of the coal-fired power plants.
Mhm.
And because they would have come out of the smokestacks, and we looked at the prevailing wind direction and the height of the smokestacks and calculated where the concentrations would be highest based upon that, and then did statistical analysis to see um, what the correlation was between and the probability that this contamination was being caused by these coal-fired power plants.
I have a question, please. Is that Lake Michigan on the right side of the map?
It is. So,
Thank you.
yep. So that's Lake Michigan right all along here. This isn't the whole city. This is like downtown. And then so this is the southwest side of the city. I think I accidentally said southeast before, but southwest side of the city where these two power plants were. And you can see that there's like um, this is about 400 parts per million of lead, and these higher levels of lead do cluster around the plants. Um, it was a very ambitious project with 470 samples collected on these two spokes, these wheel spokes. Um, some of the people who helped collect were faculty members, undergraduate students, high school students, um, members of the environmental justice organization, and then the students in the undergraduate chemistry laboratory, about 600 students, were responsible for preparing all of the samples for analysis. And the type of analysis that we do is ICP-OES, and I will explain in a second. So, and then we obviously, once we had those data, did statistical analysis of the data and mapped it like as shown in this example here. Um, so ICP-OES is an analytical technique that works like fireworks. So, or I mean, most people here, I think, are chemists, not everyone. Um, put a thumb, yeah, I see a thumbs up. Put a thumbs up if you've ever done a flame test. And if you haven't done a flame test, you have definitely seen fireworks. I assume that everybody has seen fireworks. Yes. So, so what happens, the reason that we get all the beautiful colors of fireworks is because every element has emission that is unique to itself. So lead has different energies of emission, and therefore different colors that we could either see if it's in the visible region, or that we could detect not with our eyes but with some instrumentation if it's in the UV region. Or sodium has different colors. We're often familiar with that like yellow orange color, or copper, which is a green color. So the ICP instrument measures the colors, the wavelengths of light that are emitted when when our process samples are excited um, by an inductively coupled plasma, which gives it a ton of energy. So much more than just putting it in a flame like a flame test. The plasma is equivalent to 10,000 degrees, which is the same as the surface of the sun, where there's also plasma. Um, and so you excite the electrons and then measure the wavelength of light so we can determine that lead is being emitted or sodium is being emitted or copper. And we do that for about 10 different metals typically. And then use, we can also quantify that light against known samples. that's how we can generate a map like this is first by using the ICP to get the data, and then we also have GPS coordinates so we can map it all out as shown here. So that was the first sort of like major big project that we did. I don't think we were really directly responsible. A lot of people were raising awareness about that, and the coal-fired power plants were shut down in 2012, which was great, of course. There's still issues surrounding them, which is unfortunate. Um, but a few years later, um, someone that I worked with who had been a high school chemistry teacher whose students had helped collect samples for that project was had gone and gotten his PhD and was a science uh, education researcher and put together this youth participatory science collective. And so this collective was, as I mentioned, established in 2017. And so there were multiple interconnected relationships, which I'll show on the next slide. And so we continued doing research on environmental injustice in the city of Chicago, continued studying heavy metal methods, as I just discussed, same methods, ICP, OES spectroscopy. And then we started doing even more mapping of our data as a way to um, connect the people who were being affected by these heavy metal contamination issues so that they could see the data themselves and interact with it. So the collective um, was the science education researchers. Danny Morales Doyle was the person who started the collective. We partnered with a number of high school teachers in the city of Chicago, mostly teachers in the Chicago public schools, and university scientists like myself and people at other universities in Chicago were part of the collective. As I've previously talked about, there are a lot of environmental justice organizations in Chicago, and so those organizations were became part of our collective as well. Um, High school students, the community members, and college students. So part of the idea of this kind of thing, it's a democratizing approach to doing science. So rather than me as like a trained chemist working at a university having all the knowledge, like there's different types of knowledge that other people in this collective have. Certainly, community members have their lived experience of living in these neighborhoods where there are concerns around contamination, of heavy metal contamination and related things. Like, for example, when we were working on the problem of the coal-fired power plants, it's not just that they're um, spewing heavy metals into the air, which then deposit on the soil, but also that just particulate matter in general is like causes problems like asthma and other respiratory issues. And so we kind of use this heavy metal contamination in the soil as a proxy for a variety of different environmental issues. And one of the things that's another thing that's really great about this collective was the way that we interacted with each other. So um, the high school teachers worked with the science educators to develop co-develop curriculum. High school students themselves would create their own sampling plans, their own hypotheses. They would collect their own data, do their own analysis, obviously with the support of people like me, with their teachers, etc. So we all collectively worked together on this project. And so, unlike the previous project that I talked about, where we were basically making all the decisions, but we were asking a lot of people to help collect the data. In this case, we're like involving the youth participatory science, but really everybody who was on that previous slide, all of us participating in research design, in figuring out what methods we're going to use to varying extents. Um, Collecting data. Certainly, everybody was collecting data. Students were, like I said, their research deciding where to collect samples, what's their hypothesis, what are they interested in learning, doing their own data analysis, and then communicating results. So, for example, we had youth participatory science conferences where students from all the various high schools who were participating came together and presented their results, their findings, their research to one another. Also, some of the students held community meetings within their neighborhoods and talked to their communities about what they found and why it was concerning and what people in the communities could do about that. So, and then, so it was really um, like very deliberately, intentionally being not just like has anyone heard of a citizen science or,
Yeah.
yeah, so I guess I would say that that previous project with the coal-fired power plants was more like a citizen science approach where people were collecting data, but they weren't part of the entire process. But this participatory model is like everybody is part of the entire process, which of course can be challenging and slow and frustrating sometimes because, sometimes you just want to be like, here, this is the way you need to do it. This is what you need to do. Go do it. But it really empowers students to take some control initiative and over their own work. So one of the aspects of that was that students were able to come to the university laboratories after they had designed their studies, collected their samples, and they were able to come to the laboratory to brought their soil samples with them and process those samples themselves, and then ran those samples on the ICP to get the data. Um, so here's just a little bit more about the ICP that we use. It's a pretty, um, this was also part of I guess our mission was to expose students to really high-end research grade um, equipment and so that they have, it's not just like, I mean, remember, these are high school students, that the data that they are collecting through this type of instrumentation is really high quality data and valid in a way that would otherwise be difficult for them to access. So this is an example of the data that we work with after. So um, if we're going to map it, we have to have um, latitude and longitude information. We're interested in which community areas it comes from. These were all samples that were collected recently by students at Westinghouse High School in the city of Chicago. And these are the community areas where they collected those samples. They had to keep track of the mass and the volume so that, and I cut off the other part of it, but so that they could convert the data that they got from the instrument into usable data um, based on the exact amount so that they could calculate the exact amount of heavy metals in the soil samples that they had collected. So throughout all of this time from 2017 until, or and even earlier, but really the youth participatory science collective started in 2017, and we had 10 to 15 different high schools collect doing their own analyses. And then I had already been thinking about this based on my earlier work, but um, then COVID happened and we weren't doing anything like physical, like we weren't collecting new samples, they weren't coming to the lab. And so I wrote a grant through Northwestern to hire two undergraduate students to take all of that data that had been collected by all these different high school students in all these different places around Chicago and create what's called a story map. And are you all able to see the story map or or do I need to switch screens?
It's a little small, but it's visible.
It's small.
You're talking about the lead concentration heat map, right?
It should, no, I don't think you can see it. Let me see. I'm gonna switch windows. Um,
You have to strain your eyes a little bit to see the ppm concentrations.
oh, all right. Can you see this one now?
Oh, yeah.
Yes.
Yes.
Okay. So, story maps, actually, I think when I was in the, did I hear that somebody worked for the company that does ArcGIS, Esri? Maybe not. Um, so, um, story maps are a way to incorporate map data, like spatial data with like a narrative in a website. So we created this website, Environmental Justice Injustice in Chicago, and the I can actually share the links to yeah, if you are interested later, I'll paste it in the chat. Um, so the students created this map talking about what environmental injustice is, uh, discussing the zoning in Chicago, which led to a lot of the issues of environmental injustice in Chicago. Um, So there was something called redlining, which basically like literally drew red lines on certain areas of the cities and said, Black people, you can only be in these certain areas and you can't live in these other areas. And oh, by the way, these areas where you can live are right next to all these polluting industries that Chicago is full of. Um, and there is still a very high correlation of where people of certain ethnicities and races live that has this historic origin from about 100 years ago. So this data was, so this is all of the data that so my students took all of the data that these high school students had collected and put it all together in a single map. And so, um, for example, then they went through and they looked at the data for every single one um, of the elements that we had analyzed. And some of them like are not so super interesting, but like for example, you can see here we're looking at calcium. And so these blue stars are where we had very high levels of calcium, but that's just like a natural, that's because of the limestone within like naturally occurring. That's not like a contaminant or a concern. Um, but for example, chromium is a contaminant and is a concern. And fascinatingly, like there's this giant, this isn't even in the city. This is way northwest of the city where there was like a sample collected that was hugely, like extremely high in chromium. Um, and we've never gone back out to take more samples or to figure out roll through. This is one a bit of an issue with these the way they did the map is you kind of have to scroll through, but um we were going to continue on.
Where is Northwestern University on this maps?
Aha, that is a good question. I'm going to go back because
Is the big chromium dot near Northwestern?
no, it's actually not. It's northwest of so this this area right here where my cursor is actually that's not where Northwestern is. There. So see the big glob of points right here and
Oh, that's
around
Evanston. Yes,
Evanston?
I see it.
Yeah.
Yeah.
So the reason that we have so many points there is because we also when I was the general chemistry lab director and the student this for several years the students collected samples in and around like in Evanston and in that area. So that's why, and those were included in this data here. So that's why there's such a large clump of data. Right, that's right where the university is. And wanted to show you lead. Sorry, they're alphabetical by by symbol. not by not by name. So so you see here this is the map indicating the various levels of lead and so we put together information. So anything in blue is not concerning. Uh, Greater than 300 is in red,
Right.
and that's dangerous to pregnant women and young children. Um, and then like the ones that are pure red, you see there's like one huge sample
Huh.
in Evanston that's very, very high.
Mhm.
So that is an anomaly. And I am pretty sure I can tell you why it is. Um, on Northwestern University's campus, we have something called the Rock. And it's this rock that students can paint. And this sample with this extremely high lead concentration was like a little down, like right by the rock. So I think that some students must have painted the rock with lead paint. And when other students went and sampled a soil sample nearby, that's why that was so extremely high. But other than that, you
Where
can,
is the where is the Loyola University in this map?
Loyola University is kind of right under Evanston. It's just south of Evanston. Um, that's actually where I live. I mean, I don't live in Loyola University, but I live in the far northern part of the city. I have another map that I can show later that will be, I can point out to Loyola a little better in that other map. But you can see that these higher levels of lead are circling in this area of the city, other than that one up here. And these are areas of the city which are the historic industrial areas of the city, and also where lower income people and also this is where those coal-fired power plants were. Um,
Where's O'Hare on this airport?
O'Hare is west.
Right.
Again, I have a better map that can show you better. But we, at this point in time, didn't have too many samples out by O'Hare.
Oh,
It's like sort of like
there.
here-ish,
I
where my,
see.
yeah. And yeah, so one of the things that we did with this is that we compiled all of the data into a spreadsheet so that anyone can take all of the data. Um, are you able to see that?
If you look hard, you can see it.
Okay, but it's too small.
I
Um,
mean, could be bigger, but it's visible.
okay.
I can
Um,
see that. I can see that clearly.
Yes,
okay. I can make it a little bigger.
Oh
Is
yeah.
Yeah. So
much
um,
better.
so this is all of the data that we had collected um, through like I guess you would say 2019. And this gave the opportunity to for any of the students at any of the high schools or anybody who wanted to could manipulate the data, could do their own mapping, could do their own statistical analysis. And then we also separated it like from the specific high schools that had participated in the project. So we had data that was from Social Justice High School. We had data that was from George Washington High School, from Westinghouse High School, etc. So we also, in addition to having the whole thing, we had it in separate um, in separate tabs as well. like if people wanted to look specifically at the data that was collected from their own high school. Yeah. So, um, I'm going to go back to unless somebody has any questions about the map, I'm going to um, stop sharing that and go back to my PowerPoint presentation.
Thank you.
Um,
Okay.
all right, so we're back at the PowerPoint presentation. So this project was really great because we were able to like combine all of the data together, map it. You could look at any different one of the metals and you could look at where those levels were high, also compare it to demographic information and health information, as well as historic information. Um, and once once we came out of COVID and people started, the project continued and people started collecting more data, we actually discovered that part of the problem um, with our map, with our story map, was that we um, we couldn't update it. So we were collecting more data and we were unable to add new data to the existing story map. So we created a new project, a new map in this past year. Actually, to be honest, it's not really complete yet, but we two new students were working on this past year, and our our goal was to create a new story map that could be easily updated. So we worked with a GIS expert, a global information systems expert, to um, put the data in our own data in the maps in a way into the story map that could be easily updated. Um, so, and then this particular, I just took a screenshot here, but this is a map of different samples, not the same ones that you saw before, but showing where the high levels of lead are, again, like circling around and not in the like in these what they're called industrial corridors of the city. And I can also open that map up later if we if we want to. Um, I mean, I've talked kind of around all of this issue, but um, so, so here you can see on this map, Krishna, you were asking, here's O'Hare. Um, so here's here's Rogers Park, which is the northeasternmost community area in the city of Chicago, and that is where I live. And Evanston is just north of that. And in Rogers Park, like about a mile from me, closer to right on the lake, is Loyola University, which you also asked about. And then you will see, if you're interested in the, I guess, the political aspects of the geography of Chicago, notice that there's just like this thin little line that connects O'Hare to the rest of the city. So O'Hare is really outside of the city, but the whole city limits have to be contiguous. So there's literally like one street that connects O'Hare to the rest of the city. And then this right here is in the late 1890s. Um, the city of Chicago um, annexed a bunch of little towns. So that like includes where I live, Rogers Park, all of these, all the way around the edge. But this particular community didn't want to be annexed. And so to this day, there's like this little where the gray is right here, that's its own municipality. Um, so this map shows the official 77 community areas of Chicago. And they align somewhat with what you would call neighborhoods, although neighborhoods don't have official boundaries. Um, and they also align kind of with wards, which are the political, like we have 50 wards, but of course those boundaries change every time a census changes. So this 77 community areas is the only one that has like specific official non-changing boundaries within the city, which is why I decided to focus on the 77 community areas because they are well defined and we can overlay our own data that we collect from these community areas with publicly available data, demographic information, health information, historic information, etc. Um, so to give you an idea about what Chicago, like the demographics of Chicago. Overall, we have a little less than a third of our population is white, and then slightly less than that is black, and slightly more than that one. So basically, more or less, we've got within the city overall a third white, a third black, a third Hispanic. We have a few Asians and Native Americans and other, but predominantly this is what you're looking at. And in my particular neighborhood in Rogers Park, we actually have that demographic. So we also um, have about a third white, a third black, and a third Hispanic. But it's actually quite segregated overall. So if we look at Lincoln Park, which is this neighborhood right here on the lake, um, north of the Loop, there most people probably know have heard of the Loop, which is the downtown area of Chicago. So Lincoln Park is almost 80% white,
Yep.
only less than 4% Black, and just over 6% Hispanic. Conversely, we have this neighborhood, or sorry, I am not good. Riverdale, which is way down here, in the very south part of the city, is only 1.8% white, over 95% Black, and 2.6% Hispanic. And I would like you to, um, so overall, median household income in the city of Chicago is just over $74,000. Um, Relative to that, what do you think the median income is for Lincoln Park? Higher or lower?
Much higher.
Much
Haha,
higher.
much higher. Yes, much higher. So, yes, 157,000. And then Riverdale, what do you think is the median household income there?
25,000.
19 or
Oh,
20, I guess close to 20. Yeah. So, there's incredible disparity in terms of wealth, which is very highly correlated to the predominant race ethnicities in those neighborhoods. And um, also, as you can see on my story maps, but I'm not showing it here, you will see that it also correlates to the areas that were redlined a century ago. You will see that it correlates to the areas where there are the industrial corridors, and we also have found, not surprisingly, that um, the areas of lowest income, lowest amount of whites also correlate to highest levels of contamination of heavy metals.
what about the health effects on
Oh,
this Riverdale or whatever it is called?
oh yeah. I I didn't. So Riverdale happens to be one of the areas that I don't know a lot about, but I do know because looked at, I have not specifically looked at Riverdale, but I have looked at all of these data, you know, in different ways. The reason I picked Riverdale for this talk today is because it is the lowest, it has the lowest median household income of any of the 77 community areas. Um, what we usually see are higher levels of heart disease, of respiratory illnesses, of cancers, also correlated with those areas. I can show you and can tell you that this area right here, the east side, I know more about that specific community area. That community area is where one of the high schools that is part of our youth participatory science collective is located.
Southeast.
I'm sorry. I'm sorry. Did you have a question? Oh, okay. So, um, also, um, so I mentioned before that Lincoln Park, and you see it there still on the screen. Lincoln Park is has the highest income, highest amount of whites, and historically there was a an iron an iron shredder in that neighborhood on the west side of that community area, and the um, wealthy white people in the neighborhood several years ago started a campaign to get this shut down. It was called General Iron, and they were successful, and the city agreed that it was polluting and it was dangerous for people to live close to, and therefore the General Iron needed to shut down. Immediately after they made that decision, they granted them a permit to open up another facility on the east side where um, the population was mostly Hispanic and Black, and where the income, although not 19,000, is only slightly higher than that. And fortunately, um, there was a lot of the community fought hard. Students and teachers at the high school went on hunger strikes, and this was during COVID, and they lots of protests, and um, so to this day they are not open yet. Hopefully, they will not ever open, but you know, they're pushing their on their end, and the community is pushing back. Of course, my question is, why should the community have to push back? Like the city ruled that it was dangerous for them to be operating near white people. Why is it not dangerous to be operating near black and brown people? So, anyway, that was so that is an example of this issue that I wanted to highlight.
Well, Shelby, I had a question.
Yes.
I was wondering, besides race demographics, did you look into age? Because I know like the lead can be more harmful for children. So I guess in terms
Yeah.
of the mapping, is there more kids in one area than the other?
You know what? I have not looked into the age, but that is a great point. And like that's also something that's really like great about this kind of analysis and research
Mm-hmm.
is that like you can pretty easily pull any kind of demographic information and say, oh, let's look by age and then overlay it with our own data and or other data and see, and see those results. So
Yeah,
it can be done pretty quickly. And that is a very good point, and I will add it to the add it to the list because that's
sounds
great.
good.
Yeah, thank you. That's great.
Thank you.
So um, so oh, I have to confess that although our goal is to have samples from all 77 community areas, we are not there yet. Um, I spent the summer working with two undergraduate students, and it was um, extremely difficult to get from Northwestern to the south side and to get samples from all of these communities down here. So part of what we did, in addition to collecting collecting data, let me, I'm gonna, I I'm getting better at this. I have to switch my view. Okay, so here's our list. Oh, and Asmi, sorry. Asmi, yeah,
Hi, Asmita. I was just
Asmita.
curious, was there any observation done about the species of lead, like the speciation? Because some species are like bioavailable more dangerously and more rapidly than the others.
Yes, yes. So we are just looking at lead, but we're not looking at the species at all. Like our methods completely destroy any of that information.
Uh-huh, okay. So just the
However, yes,
elemental.
yes, yes. And the reason, like, I kind of alluded to this a couple of times, but I will say that, um, I mean, yes, lead in the soil is dangerous. And as you mentioned, depending on what its form is, more or less so. Um, we um, in a lot of these places, nobody is interacting directly with the soil. Um, of course, places where there are children playing in playgrounds and where there are people who have community gardens and things like that, that's a direct concern. Um, but in addition to the direct concern of the lead, Um, there's also, as I mentioned, it's sort of like a proxy because if the lead is in the soil, especially the surface, then it came through the air, most likely, and through from industries either currently or previously, and like those coal-fired power plants. So it's partially um, a way to look at environmental contamination, like it's our way of looking at the contamination overall of different areas. So it's just one way to do that, and that's the way that we're deciding to do that.
Thank you.
Thanks. So here's our spreadsheet of the 77 community areas. So of 77, we have 29 where we feel like we have sufficient samples. We have another 16 where we have taken some, but we would like to have more. And then we have 32 where we don't have any. And most of those are on the far south side of the city, because we just haven't gotten down there. So what we have done is we have partnered, we've created plans and have implemented those plans to partner with environmental justice organizations, continue partnering with high schools and just other community members. So in addition to collecting samples, analyzing samples, mapping samples over the summer, my two students also created a sampling plan and a form where people could know how to collect the samples and then how to submit them to us. And so we have gotten um, we have gotten more samples from people like community members, members of PARO, the Pilsen Environmental Rights and Reform Organization, high school students from several of our high schools, Westinghouse High School and George Washington High School, which is the one where the students went on strike to try to hunger strike to try to prevent that metal shredder from moving in. And so these are both available online um, to allow people to um, help us keep going. And I mean, I do, as I said, I have to admit we didn't get to all of them yet, and we're struggling to get a lot of them on the far south side because we don't have a lot of connections down there. Although we do have some through the schools that we partner with. And I would like to thank NSF. That is the funding that we got for the Youth Participatory Science Project. URAP is Undergraduate Research Assistantship Program. So that's a program that pays undergraduates to work for me as undergraduate assistants, research assistants. I also this past summer received a Baker grant, and that was to have a team basically of undergraduates who worked with me over the summer. The YPS Collective, Danny Morales Doyle is the person who had been the high school teacher I had originally partnered with, but he is the one who was the PI on this, and he's a faculty member at UIC now, University of Illinois, Chicago. Nina Hike is one of the teachers that I work very closely with. Mindy Chappelle was a teacher that I worked closely with, and Adelina Ayere is also one of the teachers, and there are many more. I highlighted Maria Chavez for Pero. She is literally someone that has been partnering with me for over 20 years, which has been great. And she collected samples for me again this summer to add to those 77, to up that number towards the total of 77. And then these undergraduate students that I've listed here on the right are the ones whose work directly impacted the things that I talked about today. I would interesting like to highlight this student, Damian Bridges. Whoops. He, as it turns out, was part of the YPS collective as a high school student. He happened to be in the chemistry class of one of the high school teachers who participated in our project. And then when he got to Northwestern and saw my ad for a research assistant, was very excited to apply. And so it was very much full circle situation. And thank you. And I wondered if you had any questions. I mean, and thank you for asking questions as we went along.
Do we have any questions?
Yes, I
Christine?
have a question based on some old memories